Hello and welcome. In this video, we're going to take another look at our fundamentals demo in Java. And specifically in this video, we're going to take another look at arrays of integers. Now, in this video, we're going to focus on multi-dimensional arrays and specifically two-dimensional arrays, but everything we look at in this video then can be applied then to larger dimensional arrays. Now, the one thing that we aren't going to focus on in this video is we're not going to focus on how to resize the array. We're going to save that for another video. Instead, what we're going to do is we're going to focus on how we would declare and then ultimately initialize values in a two-dimensional array, as well as accessing those values. And so to begin with, what we want to do is we again want to create a little helper function that we are going to have. We're going to call it our ArrayWithInts2DDemo, and it is going to be a public static void again, because it's not going to accept or return any arguments. And so to begin with, let's go ahead and scroll down roughly around our help, and let's go ahead and get started. Again, we're going to have a public static void, and we're going to call it ArrayWithInts2DDemo, and no arguments passed or returned. We're going to get started with our comment block that we should theoretically be updating as we go along to describe what each one of our functions do. And let's make some quick notes here. So the goal in this video is we're going to first look at how we will actually create a two-dimensional array manually. And then what we're going to do is we're going to do another example using the multiplication table, where we actually populate the values after the array itself is being declared. So in this case, the manual one is going to be a declaration and an assignment all in one step, whereas in the multiplication table, we're going to first declare and then ultimately assign the values. And then in both cases, we're actually going to see how to enumerate through those arrays. So I'm also not going to focus on sparse arrays in this particular example. I'm going to assume that all of the rows have the same number of columns. Again, that's a little bit of a more sophisticated detail that we can take a look at in a later video. Most of the time, you're probably going to be using consistently defined rows and columns. And so to begin with, we need some variables. And so let's go ahead and start by looking at our first array. We're going to declare it much like we did the one-dimensional one, with the difference being that I'm going to use two sets of square brackets to indicate each of the dimensions. And again, probably not the base variable name. I'm simply going to call it array A. Now, as far as assigning the values at the time of declaration, well, we do it very similar to what we did with our one-dimensional array or vector, but the difference being is that we now have nested sets of curly braces. And we'll start off so that you can see how you would declare essentially a 0 by 0 two-dimensional array. Now, again, that can be used later on when we start looking at resizing here. And so what we'll do here is just note here that this is essentially a 0 by 0. So let's do one more. Again, here we're going to have an array B. That's actually going to be the first one that we're going to use. And then what we'll do is we'll follow the same pattern. We're going to go ahead and use the nested set of curly braces. But now what I'm going to do is I'm actually going to populate the values separated by commas. So I'm going to use for the first row 10, 9, 8, 7, and 6. And then for the second row 5, 4, 3, 2, 1. Now, a couple of things to note here. As I said, they technically do not have to be the same length. For our purposes in this particular example, we are going to make them the same length. And you'll also note that this is a rather tedious way of creating arrays. So hence, probably not something that you're going to do too often, although there are definitely cases for it. And so what we want to do now is we want to think in terms of indices. In other words, how can we go through and look at all the values in our array B? Well, what we're going to do is we're going to create a couple more variables here. Go ahead and declare them, both of which are going to be integers. First one is going to be a row index, and just out of caution, we're going to go ahead and initialize it to 0. We're going to go ahead and create a second one called our column index. And again, what we'll do here is we'll initialize it to 0. Please note or remember that Java has 0-based indexing. So little note here. So Java uses 0-based indexing. And so hence the lowest row index and the lowest column index are both going to be 0. Now, what I'd like to do is I'd like to loop through all of the elements in our array B. Well, to accomplish this, then what I'm going to do is I'm going to set up a nested for loop starting with the row index. And I'm going to simply hard code in the values both for the starting as well as for the ending. And so what I'm going to do here is I'm actually going to use the row count. So it's going to be less than 2. And then we simply want to increment our row index by row index plus plus. Now, we can do the same thing now for our column index. And so we'll have for column index equal to 0, column index less than 5, and then column index plus plus. Now, keep in mind now we are stopping before we hit 5 because of the fact that the column count, which in this case is 5, and the column index needs to have a relationship of essentially column count minus 1. In other words, our column indices are going to be 0, 1, 2, 3, and 4. If you accidentally try to access an element outside of your array, you will get an exception. Now, for this first example, what I want to do is I simply want to have a nice print statement. We're going to, again, just use our system.out print line, and we can make this as fancy as we want to. How about if we just simply say array B, and we'll specify now the row index. Again, with the close brackets, again, I'm just making this look nice for us. And then our column index for the second value here. And again, we want to close our brackets, our square brackets, and then ultimately we want to show the value of our array B using that row index and the column index. And I'm assuming in this video that you're comfortable with the idea of a nested loop. The idea here is, I've missed my concatenation operator. The idea here is that for every iteration of the for loop, all of the columns in the nested loop will run. So in other words, for every row, you will get every column. And so you complete all of the columns before you go back and grab another row. And so hopefully we'll see then how these values will print out. And you'll notice I've done something here, and that was kind of intentional, is that I'm kind of counting down here so we don't accidentally confuse the index with the value itself. So let's go ahead and build it. And so far, so good. It means now that we are ready to wire this up in our main. So go ahead and grab your function signature and go ahead and come up to your main and go ahead and add it to our ever-growing list of switches that we handle. So we can use our else if our args.length equal to 1. And then our args square brackets 0. And we look at the switch name, which is going to be essentially the same as our function name. Now, again, if you're following along with this and you don't have this extensive main set up, that's okay too. It just simply means that you will want to call the function and then comment it and uncomment it as you wish. So in this case, I'm simply going to call the function when that switch is passed. All right, so let's go ahead and build it again. Let's come out here to our command prompt. I'm going to go ahead and clear the command prompt. You'll notice that I'm in my classes folder, you'll notice there is my 333 package, and I just simply want to run Java EE333, which is my package, and FundamentalsDemo, which is my class that is set to run. And I want to run the specific switch, which is based off of our function name, which is ArrayWithInts2DDemo. And we hit enter. And you'll notice now that I am looping through our 2 rows, our 0th row. And then I loop through each of the columns, 0 through 4, which correspond then to the values, which we'll go down here and take a look at, of 10 through 6. And so you can see here, hopefully, the relationship between the indices and my initial assignment of the values. So 10, 9, 8, 7, 6, 10, 9, 8, 7, 6. And then on the second row, 5, 4, 3, 2, 1. You'll notice then my row index has changed in 5, 4, 3, 2, 1, but my column index has started back over. And so essentially what I'm doing is I'm going through each of the elements in each row before jumping to the next row. All right, so hopefully that one made sense. Why don't we go ahead and create a little bit of a divider here before we jump into our multiplication table. So again, I'm going to do a system.out.println. And again, just some sort of barrier here so we can see the 2 examples separately. The big difference with this example now is with the multiplication table is I do not intend to declare and initialize my array at the same time. In other words, I want to do this as a 2-step process. And so as such, I'm going to go ahead and create now one more array. And in this case, I'm going to keep with my naming convention. I'm going to use the 2 sets of square brackets. I'm going to call this one array C, but the difference is I'm going to use the new constructor. I'm going to specify that I want an integer array, and then I'm going to actually hard code some values in here. So how about if we do 6 rows and 8 columns? Now, we could hard code these values, and we could talk about why hard coding is a bad idea. But instead, what I'd like to do is I'd like to come up here and I'd like to create a couple more variables. I'm going to create one that is our row max or row count. It doesn't really matter which one you use. And then instead, what I'm going to do is I want to assign my row count equal to 6. And I want to have my column count as being 8. Now, what does that get us? Well, what that does is that allows for us to use these variables inside of our constructor. In other words, basically what you can do is you can adjust the size of your array at runtime, meaning that we could just as easily have passed these as arguments to our function, in which case then the array could be whatever size you needed it to be at runtime. In other words, no hard coding. We want to try to avoid hard coding as much as possible. Now, what we'd like to do is we'd like to actually see what those default values are in this array. And to do that, what we'll do is we'll actually set up a very similar nested for loop to which we used in our array B. As a matter of fact, to save you some time, I would encourage you just to go ahead and copy our nested for loop over and then paste it, of course, changing every reference to array B to array C. Now, the other thing that we want to do is we want to change how we have hard-coded this value in here. In other words, we have our row indexes less than 2. Well, the good news is we no longer have to do that. We don't have to have anything hard-coded. Instead, what we can use is we can actually use that variable, that row count variable. And likewise, with our column index, we can also simply just use our column max. And hopefully I've convinced you now why our column count, rather, why the variable names are very useful here. We can use them not only in the constructor, but also in building our loops. Well, why don't we go ahead and do this example on the command line so we can see what we're starting off with, and you go ahead and build it. Go back over to your command line, and we'll leave the first example alone because it's not hurting us any, but you'll see there's a lot more values now on our command line. And specifically, you'll notice that that second array has now all been initialized to 0. And you can go through and you can see, for instance, for the 0th row, there are in fact 8 columns. For the index equals to 1 row, there's 8 columns, all the way up to index equals to 5. Remember that the row index goes from 0 to 5 for a total of 6 rows. So everything looks like it's working correctly. Now what we want to do is we want to work on populating those values. Well, to keep this one simple, again, I would encourage you to go ahead and copy and paste from the one that we use to print out those values. But the difference being is, instead of printing out those values, what I want to do is I actually want to assign values to that array. Well, how we do this is much like we do it in other languages. We simply specify the array name followed by the first index or the row index and the column index. Now, the syntax is a little bit different in other languages, but this is very close to the syntax in the C programming language. Notice the use of a set of square brackets to specify the row and a set of square brackets to specify the column. Now, in this case, all I want to do is some simple operation that will demonstrate that we understand the relationship between the index and the value as it relates to a multiplication table. And in this case, it's just going to be row index plus 1 times column index plus 1. Why do we do that? Well, it turns out that 0 times 0 is not very interesting, and neither is 0 times any other value. And so essentially what we want to do is we want to shift the 0 index to a value that's more useful, 0 plus 1, 1, and then 1 times all the values in the columns, and so on. Now, to see the changes that are a result of modifying this array, we're going to, one more time, go ahead and print out the entire array post changes. So I'm going to create one more border line here. And then again, I'm going to borrow our for loop, again, leveraging these nested for loops, this time from our earlier nested example for C, array C. And then we build this. And then now when we run this, you'll see that I have my new values. We can take a second and print this slightly differently. This is not the traditional, if you would, or normal way for us to see a multiplication table. So why don't we take just a second to do this one more time? What I'm going to do is I'm going to print all except for that last column. What I'm going to do with that last column is I'm going to wait with that last column, and then I'm going to print it with a new line. To understand what I'm going to do, we are going to again rewrite this nested for loop. We're going to start off with row index equal to 0. None of that changes. We're going to continue with our row index up to, but not including, row count. But this time we're going to go ahead and increment our row index plus plus. All that actually stays the same, but our difference is going to be in the columns. And so we'll start off with our column index equals to 0. Column index less than our column count minus 1. So everything except for that last column. And then again, what we're going to do is we're going to increment our column index. But notice here how I'm intentionally stopping one column early. So I'm going to make a little note here that I'm stopping one column early. And inside of the nested for loop, I'm again going to use a system.out.println. But I'm going to keep this one a little bit simpler. I'm going to do two things here. Notice I'm going to drop the print line. I'm going to just have a system.out.print because I do not, in fact, want that new line. And I'm only going to look at the value in the array. So in this case, I'm going to print out the row index, column index value in our array C. And then in addition to that, I'm going to add, just for convenience or ease of being able to read it, I'm going to add a comma, and we'll see what effect that has in just a second. So remember to use your concatenation operator here. Now, outside of the for loop or outside of the inner for loop, I'm going to do something a little bit different. I'm going to, again, print this out, but this time I'm going to not have the comma. Instead, what I'm going to do is I'm simply going to print out the value followed by the new line. And so now what we'll do is we'll use our system.out.print line to print out our array C using our row index and our column index. And effectively what we're doing is we're leveraging the fact that the column index is now at the last column, and we are going to print out a new line. Now, this will make a little more sense once we build this and look at it. This code itself probably doesn't make any sense until you see the ultimate results here. And if you notice now, I get much more of a table view, and there are tools in Java that will allow for us to do this different ways. This just allows for us to set this up for a CSV format that we could possibly use in our file input and output. So hopefully this made sense. You get to see a couple of different ways of viewing your array, your two-dimensional array. Also, in addition to this, you should now have some appreciation of the differences between hard coding or manually assigning the values versus declaring and then assigning the values, in this case, in a nested for loop. As always, if you found this video useful, let me know. If you've got any questions, comments, or concerns, let me know. And thank you for watching.